All good. You are the free electron of this class. You are exploring all the corners and all the seats. You should do that. You will then find you have not seen Sheldon Big Bang Theory, no? It seems so you are like to trying to find the ideal spot for your sitting, where you have optimal airflow, where you have optimal audio, visuals are fine, like that. You should watch that. You'll like it. Sheldon. Okay. So, how is it going? Have you got any doubts from the previous classes? Anyone? See, we'll be writing certain questions as well. I'll be giving you some questions this weekend so that you can write them. Okay, don't worry, I'm not going to give you a lot. There could be barely 2 or 3 questions because I personally don't like homeworks. So that's the thing. Because I never did it, I don't force anyone to do it. Okay, but yes, I do remember I gave you a homework about Ethiopia. Anyone who found out the answer? Highly good. Yeah, that's a volcano which recently exploded. Okay, and during the winter months it became a little difficult for our flights to fly over Africa. Okay, so that's the thing. We'll see a lot of these things in the recent times. Okay, so today's agenda is basically to take our discussion forward with solar system. Okay, so see, you are going to read solar system in 2 stages. Today we are going to talk about solar system in general. What are the components of solar system? Okay, the next thing after we are done with this part, we'll be then talking about what exactly are the theories based upon which we have solar system and subsequently the universe. So there are 2 parts about it. Today you are learning the specifics of solar system. Okay, so when we talk about the solar system, so in the terms of physics, when you talk about physics, so there whenever you have this particular term system, physics, engineering, okay, so this system would mean a collection of similar objects. That's the first thing. And then the next thing is we focus our observation on these objects. Okay, so that is basically the meaning of system. You might be knowing this from biology that we have various systems and collection of organs which are required for various functions, just like you might be knowing about the respiratory system. Okay, you might be knowing about the circulatory system of our body, the digestive system of our body. Okay, so what do we identify this with? What are the specific functions? But when you talk about system, system is basically a collection of similar objects. Okay, so when you talk about digestive system, you talk about respiratory system, you talk about circulatory system, they basically all contain organs. That is the similarity. Okay, and together they execute a function of our body. Similarly, when I talk about you all guys, you individually are called a system of particles. Now these particles have mass. Okay, so that is why all of our bodies are different. Our heights, our health, our complexion, our agility, our endurance, everything is different. Okay, but the point is that everyone is self-sustaining. As long as you are self-sustaining, you are alive. Okay, once your self-sustenance goes, that is death. Okay, so that is how system is characterized in physics. A similar you can say description is also given in mathematics if you have done any of the aptitude classes or maybe school level or engineering level mathematics. A system of equations. Okay, that is usually the term given when you have multiple equations to solve together. And why are you solving these equations? You are solving them together so that you basically have got a solution to take. You need to find out x or y or z. Okay, so when you solve these equations together, that is why they are called a simultaneous system of equations. Do you understand the meaning of system? Okay, so now what happens is that when we talk in terms of physics or engineering, when we talk about a system, our whole observation is on that particular collection of bodies together. Just like if I have to tell you, if I have to physically characterize every individual of you, so you would be my system. Okay, you would be my system every single time I talk to one of you individually. Okay, now because you're sitting together in a class, I am addressing the class. So the overall sentiment of the class, the overall performance of the class is what I am concerned about. Do you get the meaning of system? Okay, so in this system, if I consider this boundary of classroom as a system, so I have got you as the individual sitting here. Okay, so your behavior, your aptitude, your intellect is something that matters to me, because right now my pure observation is on you. But let us say that you go to a hotel. Okay, you are traveling somewhere and you have booked a Airbnb or hotel. Where would you want to stay? Hotel is fine. Airbnb, let us say Airbnb. Okay, so you go to an Airbnb. So when you enter that particular property, that room which you have booked in, okay, so when you start entering that room, you start judging. You judge every single thing there. Okay, with respect to how was the reception, how easy was your check-in, okay, how prompt was the room service as soon as you ordered something, okay, what exactly is the ambience, okay, how are the lighting, okay, how is the network connectivity, do they have Wi-Fi, do they have warm water or not, okay, every single thing matters. So now what you are doing in that particular setup, there are no humans, but you are still trying to evaluate everything together. Yes, there are different elements you are focusing upon. Sometimes you are focusing upon the toiletries, sometimes you are focusing upon the room service, sometimes you are focusing upon the comfort of the bed, but all of them together constitute your room where you are going to stay. Okay, so whenever you shift your observation from one to the other, your system also changes. Let us say you are making a vlog, okay, that I am at this particular property and this is what I have been through and so you are doing it. Okay, so every single time you are taking the agenda to some specific thing. Let's say this is the kind of bed you are going to expect here and it is a lot of having a lot of bed bugs, so don't sit on the bed on that, something like that. Okay, so if you want to criticize it, you can go to any level. You want to praise it, you can go to any level. But the point is that every single time you are trying to describe a particular element in that particular room, that becomes your system. Is this understood? This is one of the toughest concepts to make students understand with respect to physics and mechanical engineering. For that matter, civil engineering, because there we have a lot of systems to study. We talk about it in thermodynamics. The most important part where we talk about it is thermodynamics. How to characterize a system. This is how you characterize that system. Okay. So every single one of you is a system when I am focusing my observation on you. Okay, when I am focusing on my observation of the class becomes my system. So what do you understand by this? The definition of the system is going to change with context. Okay, so when I talk about the solar system, I am going to talk about celestial bodies together. So the similarity is that all of them are celestial bodies. So what exactly comprises the solar system? It has the sun, it has planets, it has got some rocky fragments which are known as asteroids. Okay, these asteroids, when they are knocked off from their orbit, they are known as meteors. Okay, for that matter, we have comets, we have dust particles, some amount of gas, okay, some amount of ice crystals. So if you have any of these expectations in mind that beyond earth we do not find ice or water, it's not true. The only thing, water is found in such a manner in which life does not exist, or it is having either a heavily contaminated concentration of some other element, just like a high amount of carbon dioxide dissolved into it, some other kind of acid dissolved into it, that prohibits life from thriving. Okay, that's the distinction we have with earth. Do you understand this? So when I describe the solar system, it's a collection of all these solar, you can say all these celestial bodies together. So it has 8 planets. Okay, it has, along with these planets, several satellites. We don't know how many satellites yet. Okay, we have asteroids. When these asteroids are knocked off from their orbit, they are known as comets, meteors. We have comets, ice crystals, dust particles, gas. Okay, these are all the things which are there. Do you understand this? So that is what is known as a solar system. There is only one star in this system, and that is sun. Okay, that is the only star we have, and this star is going to serve as the source of energy of all the planets. Okay, so every single planet in the solar system receives the maximum amount of energy from this star because of their proximity. Now, why are they all considered together? Because they all are gravitationally bound by the gravitation of the sun. Okay, the sun is several hundred times more massive than all the other elements of solar system put together. If all of these things are put together, even then sun is more massive than them. So that is why the gravitational pull, just like we saw yesterday, for massive objects it is massive as well. So that is the whole reason that all of these objects are bound together by the gravitation of the sun. Okay, now the other way around, when we talk about it, that because of this particular gravitation, it imparts a motion to them. That is what is known as revolution. Okay, so with respect to revolution, there is a central element, that is the sun. Okay, and all the other elements revolve around it. They take rounds of this particular central star. Okay, now they are situated at different distances definitely, but they all revolve around the sun. Okay, now their speeds was given by the Kepler's law, that the farther they are, they will be slower in their motion, and the closer they are, they will be faster in their motion. Yesterday we saw a video on that, how gravitation accelerates the motion between two white dwarfs. Understand? Do you remember that? It is the same principle that you have with Kepler's law. The farther you are, the slower your velocity or your speed would be. The closer you are, the faster you would be. Okay, so that is what we understand. Now the next thing, when you talk about it, we have characterized the shape of the orbits. Okay, so when we talk about Johannes Kepler, if you remember, so at that particular time Kepler said that it is the sun which is at the center, but all the planets revolve around it in circular orbits. Now this was corrected. Okay, so this was corrected with respect to, sorry, not Johannes Kepler, this was said by Nicholas Copernicus, that we have circular orbits of the planets. But then Johannes Kepler, he basically said that no, we are not having circular orbits, we are having elliptical orbits. Now what exactly is the difference between the two? Okay, so if I have to draw a circle, okay, that's a circle. Okay, and if I have to draw an ellipse, so that's an ellipse or an elliptical path. The difference, when you talk about the center of the circle and when you talk about the center of the ellipse, so you can define the center of a circle. So from this particular center, let us say that this is O, the name of the central point. Okay, from this particular point, all the points, all these points are at equal distance. Okay, this is what you know as radius. You must be knowing this, that from this central point, all these points are at equal distance. Okay, so that is why for a circle you have a center. Okay, and when you basically put your compass here, the needle of your compass here, and you extend your moving arm that has your pencil, and then you rotate that particular thing, you get a circle. Okay, so it is a symmetric figure in all the dimension. You see x-axis, along the x-axis it is symmetrical this way. If you have a y-axis, it is symmetrical in these two parts. Is this understood? But when you talk about an ellipse, it does not have a center. Why? Because here you do not find any kind of center. What exactly would be the center from which all the points are at equal distances? So that is why what happens is that in case of an ellipse, because you do not have such a point from which all the points are at equal distances, here we have something else. Here we have something called as focus. Okay, so every circle, whenever it is going to be compressed or flattened from any of the sides, it will result into an ellipse. Okay, have you ever donated blood? You have donated blood, so you are always given that soft cushiony ball for you to squeeze. So as soon as you squeeze that ball, what happens? The shape of the ball changes. The ball actually bulges in your palm a little bit. It may not bulge a lot, but it will bulge a little bit. Why does that happen? Because the geometry is distorted. You compress it and it turns into an ellipse. Okay, so when you talk about an ellipse, what happens is that there are you can say two axes. One is called as the major axis, one is called as the minor axis. So we do not need to get there, but what we need to understand is that on one of the focus we have the sun. Okay, so the sun is basically present on one of the focus. There are two foci. Okay, the plural of focus is foci. So in between them, on one of the foci, you basically have the sun. Now if you talk about it, so you are going to see one thing very apparent, that if I have to characterize the distance of various points here, they are going to be different, right? If I have 4 points A, B, C and D. So with respect to this entire concept, we see that as per the figure, the closest point which you can see visually is A. With respect to the sun, the closest point is at A, the farthest point is at D. Okay, so what can we conclude about the planets or anything that is revolving around the sun? That they will have some point which will be closest for them with respect to the sun, and there will be some point where they will be furthest from the sun, right? So that is why this is true for all the planets. This is not just for the Earth. So that is why the closest planet, closest point is called as, if you remember, what did I tell you? Perihelion. And this would be called as aphelion. You all remember this? Very nice. Okay. So one of the reasons why do we have various seasons on the Earth, or for that matter any other planet, would be the variation in the distance. Because when you are closer to the sun, you will feel warmer. When you are away from the sun, you should be feeling colder. Okay. This is one of the reasons. The main reason is something else. Okay, we'll be studying about that reason as well, but this is one of the reasons. Also, what you can say is that when you are closest to the sun, the gravitation will also be great. When you are furthest from the sun, the gravitation would be less. Okay, so that is why what we see, that because of this we have another phenomenon. Do you understand tide? Not the surf excel tide, tide which is there in the water. Okay, so that tide is basically a result of the gravitational interaction of sun and moon with respect to the water. Okay, why does this happen? Because when you talk about the sun or the moon, so with respect to the earth, the moon is taking rounds of the earth, so it is also having an elliptical orbit around the earth. It has an elliptical orbit. Okay, so in that particular manner, what happens is that you will be finding that at some point the moon is going to be very close, and at some point the moon is going to be far. So when the moon is very close to us, that is something which is known as a supermoon. Why? Because when the moon is very close to us, it will look larger than its usual size. Okay, that is known as a supermoon. We recently crossed the supermoon in January. Okay, so this usually happens. Then when it is going to be closest, it is going to have a very strong influence of gravity over the surface of the earth, and the only thing it is able to attract significantly is the water. So the water actually starts from the surface of the earth, it starts getting attracted towards the moon. Similar is the case with the sun as well. Because of their gravitational pull, the water actually starts rising from the surface of the earth towards them. Okay, and that vertical movement is actually known as a tide. Okay, so tide is something which is very important for navigation purposes, for fishing purposes. That is something that we will be studying extensively when we do climatology. Okay, but as of now you should understand what exactly are the various things. Is this clear? Any issues till here? Okay, so this is what has been characterized, that it is not circular, it is elliptical. Okay, that is one part of the story. So that is why in this particular you can say month of March, we are going to have another event astronomically, and that is basically going to be known as an equinox. Okay, between 21st to 23rd of March, we will be moving into a time where the length of the day and the length of the night are going to be the same. Why? Because of the relative position of the earth with respect to the sun, and second, because of the axial tilt of the earth. Okay, these are the two things that we are going to see. Any doubts still here? Good. Then when we talk about the solar system, it is natural that you imagine this. Have you been to a campfire or bonfire? Have you been there anytime? So just imagine that you are sitting around the campfire. Don't sit on the campfire unless you want to become a tandoor. Don't do that. Okay, so all vegetarians, I'm very sorry, but this is what usually is the way that we refer it in the non-vegetarian parlance. Yeah, so what happens is that imagine that you're sitting around the bonfire. Okay, it's a pleasantly cold night. It's not very cold, but yes, when you have some amount of warmth, it still becomes pleasant. Okay, so when you're sitting around it, you feel warm and comfortable. Now let us say that your friend say go and fetch something, let us say from the outhouse or whatever property you have booked. Okay, you have something there that you want, maybe a guitar, maybe something else. So what happens is that as you move away from the source of the fire, that is the campfire, bonfire, you don't feel the warmth. Is it true? You will not feel the warmth. And if you are sufficiently far away, you will not even feel any kind of, you can say, sensation of warmth. Okay, so what happens is that at this particular point you are going to feel only cold. Now let us see that you are actually going to fetch your guitar and you go back. So as you approach the campfire, again you are going to see that after a certain distance you start feeling warm. Okay, and that warmth keep on increasing till you reach the location where you are supposed to be performing, right? Exactly the same way we have the setup of the planets as well. Okay, so planets are also arranged in a similar fashion. They all don't sit together in the same orbit. They have their own orbits which are located at certain distance from the sun. So what happens in that particular case? You will find that when they are located at certain distances from the sun, the warmth is going to reduce, and because of this warmth reducing, what happens is that when you reach beyond Mars, when you go beyond Mars as a planet, the temperatures are always sub-zero, below 0 degrees. Okay, and that is why these are always frozen. But as you come from Mars towards Mercury, you see the temperatures progressively increasing, and because of this increase in temperature, what happens is that water cannot remain as ice, it cannot remain frozen. Okay, so on Earth we find it as liquid water. Okay, as you go towards Mars, you go towards Mercury, the temperatures are greater, so any kind of water gets completely evaporated. Okay, any water that might be there completely gets evaporated, and subsequently what is left behind is only that part which cannot be melted, and that is rock. Okay, so as you move from Mars towards Mercury, what you are going to find that all the planets are rocky. Why rocky? Because they cannot retain ice. The second thing, they cannot retain gases. When you heat something up, let us say you are heating a pot of water, it generates vapors. Okay, so it is only natural that when you are moving from Mars towards Mercury, you are going to find that subsequently the amount of heat that is going to be received by them is going to be more, and when it is going to be more, you will not be able to have the gases trapped as frozen. They will turn into gases and they will leave the surface. Okay, the greater the amount of energy, the faster they are going to leave. Okay, but when you go beyond Mars, you go to Jupiter, you go to Saturn, Uranus, Neptune, so what happens is that they are far away first of all from the sun, so that is why the temperatures are very very cold. The second thing, they are very massive. So what happens is that in this particular reality, the gases are frozen, and then they are very tightly bound on the surface of the planets. Okay, because of their very strong gravity. So then what happens? The gases are found as frozen, okay, in the frozen state on the surface, and these are known as gas giants. Okay, so the inner planets, Mercury, Venus, Earth and Mars, they are known as rocky planets, terrestrial planets. The outer planets, Jupiter, Saturn, Uranus, Neptune, they are known as gas giants or Jovian planets. Okay, so that's the difference of composition which comes up due to their relative positioning with respect to the sun. Okay, so our solar system has got 8 planets. Okay. Earlier we used to say we had 9 planets including Pluto. Okay. But because of the improvement in astronomical observation, we found out that there is good reason that the planet Pluto cannot be considered a planet. Okay. Why is that so? We are going to learn that as well. So now we have 8 planets. Okay. And we have several dwarf planets. We have asteroids, meteoroids, comets, dust particles and gases. Okay. So these inner planets, Mercury, Venus, Earth and Mars, they are known as terrestrial planets. Okay. And Jupiter, Saturn, Uranus and Neptune, they are known as Jovian or gas giant planets. Okay. So do I have to tell you the positioning of these planets, or do you remember this on your own? You remember them? What is the sequence of their position? Okay. So Earth is basically the third planet with respect to the Sun. Okay. So that's the thing. Now see how the things have changed. I told you that Mercury, Venus, Earth and Mars are terrestrial planets. Now the title here is terrestrial worlds. So terrestrial worlds are all those celestial bodies in the solar system which are rocky. So it means that it will also include those natural satellites which are rocky. Okay. So terrestrial planets and terrestrial worlds, that is the fine line difference. Do you understand this? Okay. So terrestrial worlds will have greater number of bodies. Terrestrial planets, only 4 bodies: Mercury, Venus, Earth and Mars. But when I say terrestrial worlds, it will include Moon. It will include the natural satellites of Mars as well, Phobos and Deimos. It will include the natural satellite of Jupiter which are rocky, like Europa, Io, Ganymede. Okay, it will have the moon of Saturn which is known as Titan. So they are all celestial, they are terrestrial worlds. So what exactly is the distinction? That they are all going to be rocky or made out of rocks. Okay, so these are the 4 planets, and apart from that you have other natural satellites, example being Moon, Io, Europa, Ganymede, Callisto. These are the Galilean moons. I told you Galileo actually observed the first 4 moons of Jupiter. That is the name. That is, they are known as the Galilean moons. So they are Io, Europa, Ganymede, Callisto. These are known as the Galilean moons. Okay. Out of this, when you talk about Ganymede, currently this is the largest natural satellite of any planet in the solar system. Ganymede. Okay. So when I was studying in the school, it was said that your Jupiter has 47 natural satellites. But the last time I checked, it has 97 natural satellites which have been discovered. Okay. So that is basically how you see the you can say the Jupiter, the natural satellites of Jupiter. Then you have Titan. Okay. So Titan is a moon of Saturn, and it is also one of the most promising candidates of the existence of life. Okay. Then we have Triton. Triton is a moon of Neptune, and then even Pluto is a rocky terrain. Now this is exactly where Pluto starts deviating from the concept of planets. Why? Because all the planets beyond Mars are gas giants. Okay, they have frozen gases on their surface, and here you are having Pluto as one of the terrestrial worlds. Pluto is the furthest from the sun. So technically it is the coldest, minus 247 degrees Celsius. That is the surface temperature of Pluto. Okay, but again it is something which is wrong. Understood? Now when you talk about that the shapes of these particular worlds or planets, they are not always spherical. Okay, why are they not always spherical? They are because they are always dented. Okay, imagine that you basically are moving on the road and you see a car which has crashed into some other thing. So what do you see? The surface of that particular car is going to be some amount in some amount deformed. Okay, it may have a, you can say, a depression on some of its parts. What do you call it? You call it dent. Okay, for that matter, if you have ever played cricket, thrown a ball on the windshield of a of a car, it gets broken sometimes, not always. Okay, sometimes it gets broken. What happens is that you see that even today, if this recently happened with me, because I parked my car and something fell on my car, and subsequently it did not break, the glass did not break, but yes, it had the complete fingerprint of what actually fell down on it. Now my glasses are bulletproof, so that is why it did not break completely. But yes, it had a depression on the surface, and when I was sitting inside the car, it was like, okay, some kind of boulder fell over my car. Okay, and the glass did not exactly shatter, but yes, it was not also very useful. Okay, so what do you understand? That is called as a dent. Okay, so when you have multiple dents on your body, okay, so what happens is that instead of retaining your solid spherical shape, you will be having some amount of deformity. Okay, and that deformity is basically the characteristic of all of these terrestrial worlds. What has been seen is that throughout the history of the universe, there have been a lot of collisions of these, you can say, planets with smaller asteroids. Okay, there have been a lot of things which have crashed. This is also one of the reasons why dinosaurs got extinct on the surface of the earth. Have you watched Ice Age? Seriously? Before we finish this chapter, there are 4 parts of Ice Age. Please go and watch them. Okay. And before I finish physical geography, make sure you have watched them. It's a very nice movie, and you'll find a lot of things which are here from geography there. They explain it in a funny way, sometimes also factually incorrect, but at least you get a visualization. Okay, so watch that. Ice Age is a very nice movie. There you are going to find about it. Okay, it basically covers how exactly, you can say, the things evolved till now. Why did the dinosaurs go extinct? Okay, that is something which is there. So you'll find that movie very nice. It's an animated movie. You should watch it. Okay, so when you talk about these things, so that is how we understand that they are not going to have perfect spherical shape. But yes, from a distance you cannot figure that out. Just like when Galileo said that when you talk about the moon, the spots on the moons are actually craters. What are these craters? The same dents. Okay, but the point being that when you talk about the moon, okay, so from this far, what we see moon, nothing more than a coin. Okay, it seems like a coin. So from this far you don't find that deformities, but when you approach the surface, you find those deformities. Okay, just like when you're walking on a very, let us say if you are, let us say, visiting Tumkur. So from a very far distance, you're not going to find, the road seems to be very narrow when it is merging with the hills. But as you approach the hills, you still find that the roads are going to be wide. Okay, the same thing happens in Ladakh. Ladakh is absolutely deserted. Absolutely deserted. Okay, and you don't feel like it feels like you are walking on you are traveling on a very narrow strip of road from a very far distance. When I was actually descending towards Ladakh on my bike, I saw a very big military truck, and it looked this small on a track like that. And then subsequently I went there, and I said, how would I be looking from there? Am I a point or even a line? How would I be looking? But that's a very, very wide road. It's wider than this room. Very wide road. But it looks very, very thin. Okay. So that's the magic of distance. Okay. Now, going to the Jovian worlds. Jovian worlds are basically the worlds which are Jupiter-like. Jovian actually comes from the word Jupiter. Okay. So anything which has the characteristics similar to Jupiter are known as Jovian. So these are basically the planets which are found beyond the frost line. Frost line basically means the line beyond which the temperature never rises above 0 degrees centigrade. That is the freezing point of water on Earth. Okay, that is basically known as the frost line. So beyond this, everything is permanently frozen. Okay, so that is basically Jupiter, Saturn, Neptune and Uranus. Oh, sorry, Uranus and Neptune. So why exactly are they called Jupiter-like? Because they all are giant. Okay, they are much bigger than Earth, very, very big. and because they are big, they are also massive, and because of their high mass, they have great amount of gravity. The only difference, the surface is made out of gas, frozen gases. The surface of Earth is made out of solid rocks. That's the difference. Okay, so they are gaseous, non-solid in nature. So that is why, tell me that you basically have a foam. You have seen a foam? Okay, that could be Scotch Brite, that could be a foam based anything, and you, let us say, you at the same time have a spoon in your hand. Which one is going to be heavier? Metallic spoon, not a bamboo spoon. Spoon, right? I have to be very specific sometimes. So the spoon is going to be heavier than the foam. Why is that the case? Because the foam is something which has a great amount of air trapped into it. Although it is a solid, but it has a great amount of air in it. So it has a very, very light weight. But when you talk about a spoon, spoon does not have any air. It is a solid object. Okay, that is why it is heavier. When you put both of these in water, the spoon is going to sink to the bottom. The foam may float. Unless it has absorbed water, it will still float. Okay, that's the difference between the Jovian planets and the terrestrial planets. The terrestrial planets, because they are solid, they are made out of rocks, they are heavy, and because they are heavy, they are more dense. Okay, when you talk about these planets, these are basically the ones which are made out of gases. Gases are less dense than solids, so that is why they have less density. And based on this, we come to the next conclusion, that Earth has the highest density in the solar system. And the reason for this, the core of the Earth is made out of iron. Yesterday we were discussing iron is the last element that can be formed before the star dies off completely. Its core is made out of iron and nickel, very heavy metals. Okay, so the average density, do you understand density? Density is a physical quantity that is a ratio of mass of the object upon its volume. Now Earth has a great mass because of its rocks, but at the same time, when you consider the size of the Earth with respect to the size of Jupiter, Saturn or Uranus, the size is small. So because the size is small, the volume will be small. When the volume is small, the density is high. That's the reason. Now another question would be, why is it the densest object? Why not Sun? Sun is very, very massive, true. Its volume is very, very less. Its volume is also massive, very massive, but made out of hydrogen. Hydrogen is the lightest element. It is the lightest element, and it is made primarily of hydrogen. Hydrogen is getting fused and preparing helium. Now helium is the gas you fill in those balloons and they rise up in the atmosphere. Okay, so that is very light. That is why the densest object in the entire solar system is Earth. That's the reason. Okay, got it? Sure. Now the next thing, which is called as the Goldilocks zone. Okay, so again go back to the same example of bonfire. Okay, some of us are polar bears like me. We don't like a lot of warmth. Okay, some of us are very sensitive to cold. We like to remain a little bit warm. So what happens? The people who want to remain warm will sit close to the bonfire. People like me, we will stay away from the bonfire, not because we are fearing fire, but the point is we do not have comfort with that amount of warmth. So what basically happens is that you find that there is some maximum limit till which all of us can be experiencing that warmth. Okay, and beyond this we will not be able to experience it. So if we are supposedly, let us say that we all are sitting around the bonfire and we are playing passing the parcel. So there is only a certain distance till which we would want to sit. Okay, not all, let us say you all, my students from Delhi, my students from Chennai, all of us join together. So because we are a lot of students and I am the only one, I take that space of two individuals, we have to go for a bigger circle. We cannot have a smaller circle, okay? But even in that circle, there is a maximum size, maximum distance till which you will be able to feel the warmth, and you would want to play that game. If it goes beyond that, you are not able to experience the warmth, you would not be sitting there for a long period of time, okay? So this maximum distance from the source of fire is where your activity of passing the parcel is possible. In a similar fashion, when you talk about the solar system, there is something called as the habitable zone. So this is the maximum distance from the star till which you can be having a planet located that will have the possibility of liquid water, that will have livable temperatures, and subsequently this is the zone where you are going to find the highest probability of life. That is known as the Goldilocks zone or the habitable zone. So basically we imagine the distance to be roughly the same as the distance of Earth from the sun. Why do we do that? Because this is the only planet that has got life, okay, where liquid water can sustain itself, where temperatures are such that life is possible, okay. The gases are not very hot, so they do not escape. There can be a definite atmosphere and subsequently life is possible. So this habitable zone or Goldilocks zone is something that we are always in the quest of search in astronomy, okay. So that is why this is basically a range of distance. So range of distance basically means that there is going to be a collection of such distances from the center, or that is the star. From there are going to be certain you can say optimal distances which are going to be considered a part of the Goldilocks zone. Beyond this, because of the adverse temperatures, absence of water, there cannot be any source of life. Because for us, we have understood one thing: life is not possible without water. You will need water, okay? Because when water is going to split up, it can produce oxygen, okay? But nothing combining together can produce water. So water is something that we need, okay? So that is why it is something which we characterize in terms of surface water, okay? So these are basically the ones which are very, very closely studied, okay? Now the next part we have are something called as comets, okay? So comet is not the same as MG's comet, okay? Comet is something that we see as Halley's comet, okay? Now these are certain objects which are found in the solar system, and they basically have a very eccentric orbit, okay? Do you understand this word eccentric? Do you understand this word? What is eccentric? I'll give you an example. And this is another one of my students, a very promising candidate who might either one day become a civil servant or he is going to become a politician. But one thing is for sure, he is going to be either of these. Okay. Now this guy is a very different guy with respect to what we usually attach as the features of a male. Okay. This student of mine actually is someone who promotes conservation of nature. He is an avid activist, okay, very, very nice ornithologist, very beautiful photographer, okay, and at the same time he is an activist for gender equality, okay. So many a times he would come to the class wearing a pink hood. I have never seen someone that bold. Proper pink hood or pink shirts he would wear on many days. Do you have pride parades here? Do you understand what's a pride parade? How many of you understand what is a pride parade? Okay, none of you will. You understand it? Do you know about the LGBTQ community? Okay, so when they basically come together, okay, they actually take out a very beautiful, vibrant parade. That is something that happens in Delhi, it happens in Mumbai. Not sure it happens here or not. Okay, so that is basically a parade in which they celebrate their individuality. That they come out in the open and they actually talk about it. That okay, we are lesbians, we are gays, we are transgenders. So that is basically a way in which they want to express themselves as a functioning member of the society, and at the same time also freely expressing what they feel about themselves. Now there are two things to understand. One, that you fill in your examination form, in any of the application form, that is called as sex. The second thing is gender. There is a difference between the two. When you talk about sex, so that is basically biology. Okay, it talks about your reproducing organs that are given to you by nature. So by sex, there are only two sexes, females and males, because of the reproducing organs. Now when you talk about gender, now gender is something which is personal. Okay, now this is something how an individual perceives their role in the society. Okay, so what basically happens is that there are certain times when individuals do they might belong to females or males as sex, but they do not identify their features or their activities, their thought process. It is not similar to how they should be. Okay, they could be more interested on the you can say they have a more better similarity with the other gender, other sex. Okay, that happens on both the fronts. Okay, that could be a female feeling like a male from inside, that could be a male feeling like a female from inside. Okay, so in that particular manner, what happens is that how do you perceive is basically what is your gender. So from the very beginning, we have been very strictly told that you are a girl, you are a boy, and we have been associated with certain characteristics. But at the same time, there are some of us as individuals who do not share the same characteristics in which we have been molded into or conditioned into. Okay, just like if you are a boy, you're not supposed to be crying. You are basically given relatively more amount of freedom than the girls. Okay, if you are a girl, you are expected that by the middle school you basically at least start entering the kitchen, start helping your moms with chores. Okay, at least have some amount of basic cooking skills, basic embroidery skills. We guys don't do it. By the middle school we are expected to drive or ride bikes. Okay, so on one end, the females of the family, they basically are on the end that you should be heavily protected. I don't know from whom. And then on the other end, it is us, the males, who go out and we are in the brawl all the time. Okay, so why the difference? Kyunki main ladies hu na. That's the thing. Okay, so there is absolutely no issue that a girl cannot conduct herself properly in the society. It's only our setup that okay, girls need to be kept inside within the four walls. They should be more you can say having great amount of decorum in them. They should be someone who should be very good at following the orders, whereas we males, we don't care. We don't care, we simply don't care. Okay, we are someone who can very easily go anywhere. We don't have to ask twice that we want to go out, spend the night out. That could be a restriction in some, but usually it is not the case. You want to go out to some other city to give your examination, that's fine. Okay, because you are a male, you are supposed to be doing it. You are the bread earner of the family. While the female, someone who is going to raise the family. That has been the setup of the past. Now you are here. You are not here to run a family. You are sitting here to run a country. You are sitting here to run a district. Now this role is something where you are going to see a lot of resistance from your own parents, your own family. Even if you become a collector, a district collector, you may become a secretary, you still will be questioned. You have given priority to work than your family. The same thing is not going to happen to males. It is never going to happen to males. You should be working out. Go, end your life, just earn money. That is how it will be. But what happens is that some of us do not identify with these traits. And that is why we feel differently. There are a lot of boys who secretly they dress up as girls. They like doing makeup. And there are a lot of girls who basically like the adrenaline push of the boys. Okay. So these are the individuals who feel themselves conflicted. And in order for this conflict to go away, okay, we have recently started with this practice of LGBTQ community. This is not something which is a concept that is accepted by all. You know Donald Trump, you know Vladimir Putin, two leaders of the very, very powerful countries. Both of them do not subscribe to any kind of such, you can say, alterations from Mother Nature. But now the things are changing in other countries. At least in India, since 2017, we have a genuine recommendation and recognition that there are someone who are transgenders. Okay, there are someone who may have homosexuality as their preference. You may not be interested in the other gender or other sex. You may be interested in your own sex. Now that is something which the Constitution of India now allows because of the Supreme Court's interpretation. So that is why gradually and gradually there is something called as a pride parade which comes out, that you should not be ashamed of who you are. That's the whole concept of pride parade. So this guy during the pride parade would come wearing, the pride parade is something where you will find that the individuals, whoever are trying to express their solidarity, they would have some element of rainbows. Okay, the rainbow colors, they would have something, they would have some kind of words written on their t-shirt, or they would be having a tattoo, they could be having some kind of eye makeup or things like that. But rainbow, there are different colors to an individual. That's the thing. He would come to the class wearing those shirts. Okay, so one day what happened was that when during a cold morning in Delhi, he basically was coming to the class and he was wearing a pink hood, and he had covered his head with the hood. Okay, so there is a system in Delhi that females are not charged a ticket in the public transports, in the buses. So the conductor of that particular bus exempted his ticket. He exempted his tickets while his other friends, they were all sitting together, they paid, but he was not allowed to pay because the conductor thought she is a girl. Okay, and these guys were very happy. They came to me in the class and they were like, sir, this happened today. Well, very nice, Himanshu, you are doing something very nice. So this guy is like, I don't care about the world, I care about what I feel, and I'm going to express it to the world. So the world walks in a certain straight path. Those people who do not walk on that path are known as eccentrics. Okay, I am also one of those eccentric. Okay, but the point is that my eccentricism is different. Okay, I don't identify with the norms of the society. So it means that I am the king of my own world. And that is how I should be. Who's there to question me and why should I answer you? That is what eccentricity is. Okay, when you're not following the path which is shown to you, you're doing something else. There's a very famous poem from Robert Frost, The Road Not Taken. Anyone who has heard that poem? Read that poem, The Road Not Taken. The road which is taken is always well developed, well defined. The road not taken is one such road where you have to find your own way. It will be thorny, it will be bushy, it will be shady, but you have to find your way. Very nice poem. Okay, I think it is Robert Frost who wrote that poem. So read that poem. That's not a very long poem, very short poem, maybe 8-10 lines. So that is how it is. So eccentric, now with respect to physics, is something which is off center. Okay, so center is basically defined based upon an axis. For example, if you look at this door, so this door is something which rotates about a hinge. Okay, there is a hinge on the side, you pull it from the other side. So what exactly is the movement of the door? This is the movement of the door. So from you look at it from the top, what do you find? What kind of figure it is making? A circular figure. So what you have to understand, that in order to rotate, you should be having an axis. It may not be a fixed axis, but you will need an axis. Imagine a spinning top. So when there is a spinning top, you launch that top, so it spins on its nail. Okay, but that nail is not fixed to the ground. The top moves with the nail. So what does this tell you? That you need an axis of rotation. Okay, there should be some axis around which you are going to have that rotation. So with respect to this door, there will be the hinge, the door hinge. Okay, and with respect to the door hinge is going to be the you can say the static part, and the moving part is the other end of the door. What you will see from the top, that the movement is a semicircular kind of movement. Okay, in a similar fashion, what happens is that if this is the axis of rotation, if my elbow is the axis of rotation and I get a rotation here, if instead of the rotation coming here, if I have the rotation going here, so the rotation would be something like this. But ideally it should rotate from here. This is what is known as eccentricity. How far away you are from the axis of rotation. With respect to humans, how far away you are from the standards of the society, that is your eccentricity. And with respect to physics, how far you are away from the axis of rotation. So that is basically what is known as eccentric. So as I told you that there are defined elliptical orbits on which planets revolve around the sun. But what happens about these comets is that they have eccentric orbits. It means that they basically have a very ill-defined orbit or ill-defined path when they are revolving around the sun. Okay, so let us say that this is the sun and everyone is revolving in this particular fashion. Okay, they are revolving around the sun in this fashion. Now these comets, they will be revolving in this particular fashion, completely away or completely exceptional to what should be the ideal approach. So that is the eccentric you can say concept of comets. Now where exactly are they found? They are found beyond Neptune. Okay, so beyond Neptune we have a lot of scattered rocky and icy objects which are there beyond Neptune. Okay, and that zone where we have all these scattered rocky and icy objects, they are basically known as the Kuiper's belt. Okay, so when we talk about Pluto, Pluto is an object which belongs here, Kuiper's belt. Okay, and when you talk about the other way around, beyond this particular zone, beyond Pluto, beyond the solar system, there is another such zone of scattered matter that is known as Oort cloud. Okay, so these are all the remnants which could not be absorbed or which could not become a part of any of the planets. So they are scattered, and these are the evidences which we say that when there was an explosion, so that explosion must have created fragments. These fragments are the ones which are scattered throughout the universe. So this is what gives you the evidence that these are all remnants of the past fragments. Okay, so we have seen how a star dies. So when the star dies, it also creates a very violent explosion. Any explosion is going to break things into smaller and smaller pieces. So these pieces find themselves in the universe scattered. Okay, depending upon the size, they could be dust, they could be rocky objects as well. Okay, now let us say that there is a particular very violent collision between two objects, and because of this violent collision, what happens? Both of them break down. So when they break down, where will these fragments go? Eventually they are either going to crash into the sun or they may get displaced to the outside. This is how you find comets. Okay, now why exactly are they called comets? Because of their eccentric orbits, they do not have a defined time period of revolving around the sun. Just like when we talk about Earth, Earth takes 365 days to revolve around the sun once. This is something which is different for the comets. You cannot define, you cannot characterize it. Okay, so that is why what happens is that these comets, they are someone who have a defined amount of life. These comets are basically made out of rock and ice. Okay, so every time they are coming near the sun, they lose their ice starts melting. Okay, and every time they get far away, that amount of lost ice is gone. So let us say the comet initially was this big. Okay, but when it crossed the sun one time, it changed into this, the size changed like this. So now it will be like that. The next round, another small, you can say, reduction in the size, and eventually this is going to completely fragment out. So when you talk about comets, comets are not eternal. They will eventually fragment out and crash into the sun. Their objective is to crash into the sun. But what happens is that because of the presence of other planets, because of the influence of their gravity, they are eventually unable to get through that particular point. But as the mass reduces, the gravitation also reduces, and eventually they crash into the sun. Okay, that is their ultimate, you can say, end. Understood? So comets, whenever they make a pass near the sun, they lose mass. They will always lose mass. Okay, a part of their ice is completely gone, and it cannot be regenerated because they don't have anything to freeze. Okay, understood? Now this is something that we will be learning later on as well, that when we talk about the planets of the solar system, so they all have a spin. They're not only revolving around the sun, they also spin on their axis, and most of the planets spin or rotate from west to east. Okay, from the west direction to the east direction most of the planets rotate, and that is the whole reason that the eastern side sees the sunrise while the western side sees the sunset, because we are rotating from west towards the east. So whatever is towards our east, okay, like Japan, you have Korea, okay, you have parts of Russia, you have Malaysia, Brunei, Singapore, so they are to the eastern side. They basically have this day beginning in much more advanced than us. Okay, so let us say that the sunrise in Bangalore happens at 6 o'clock in the morning, let us say hypothetically. So the sunrise in Bangalore is at 6 o'clock, 6 o'clock in the morning. When you talk about Arunachal Pradesh, the sun has risen by 4 o'clock. Why? Because with respect to Bangalore, Arunachal Pradesh is something which is very towards the east side. So when the earth is rotating from the west towards the east, it is the Arunachal Pradesh which is going to find the sunrise coming at the very first instance. That is the whole reason it is known as Arunachal. In Hindi, Arunachal is basically the land which receives the rising sun. Arun is sun. Okay, so the first reception of the sun is at Arunachal. Okay, that's the reason it is called as Arunachal Pradesh, the first state in India to see the sunlight. Okay, and now when you talk about the sunset, so let us say the sunset is right now is happening at around 5:50 conservatively. Now let us go towards Ahmedabad, or let us go towards Porbandar. Do you know Porbandar? Porbandar is in the west coast. Okay, Porbandar is also the birthplace of Mahatma Gandhi. Okay, so Porbandar is basically on the west coast of Gujarat. So the sunset in Porbandar usually happens at 8:45 in the night, even today. When I was there in one of the port towns of Gujarat for a 15-day session, 8:30 p.m. was the time when the sun would set down, and the date was 25th December. Okay, and the sun would rise up at 9 o'clock in the morning. So it was very convenient that we do not have to rise up before 9 o'clock, but yes, once you have risen up, you cannot go back before 8:30. Okay, so that is how it is. Why? Because with respect to Bangalore, it is much to the west. Okay, so that is why another example if I can give, but only I think you would be able to relate with that. Okay, because this is related to Hajj pilgrimage. Do you know Hajj? Hajj is a pilgrimage that Muslims usually take once in the life. So what happens is that when you have to go for Hajj, you basically take a flight either from Bangalore, Trivandrum, Mumbai, Delhi, Calcutta towards Saudi Arabia. Now Saudi Arabia is towards the west. Okay, so let us say that you start from you can say India, from any of these places. Let us say at 8 o'clock in the night. Okay, so when you actually start at 8 o'clock in the night, you are expected to reach after 3 hours. So in India, the time would be 11 p.m. But the person who reaches there, the time is still 8 p.m. Why? Because that is on the west side. Anyone whose friend is in Dubai or someone who travels to Dubai, you know that there is a 3 hour or 2.5 hour time difference between the two sides. Okay, you might be sleeping, your friend just would be finishing their dinner, right? That difference comes because we are rotating from west to east. Now what happens is that when we talk about Venus and Uranus, these are two planets which are known to rotate in the exact opposite direction. Okay, Venus and Uranus, they rotate from east to west. So there the sun rises from west, sets in the east. For all the other planets, we have the sun rising from the east, setting in the west. Do you understand this? What is the reason? I'll tell you, and I'll also show you this with a video tomorrow. Understood? So this was a question from 2014, sorry 2017 UPSC. Tell me the answer. A. How many with A? 3 of you. Okay. See, how many would see? 4. Okay. The central axis. Tell me your answer. A. And you, sir? C. Going with the majority, or you have a reason? You have a reason. So what is your final answer? You will go for C. So then majority. Okay. Okay. The question is, the term Goldilocks zone is often seen in the news in the context of the limits of habitable zone above the surface of the earth, regions inside the earth where shale gas is available, search for earth-like planets in outer space, search for meteoroids containing precious metals. So with respect to Goldilocks zone, we understood one thing. It is a search for such conditions which are optimal for life, right? So optimal temperature which can sustain liquid water, and because of water we can expect some amount of oxygen eventually. Okay, that is one thing we understood. Then I also said that this is something which we use for searching those planets where life is possible. Okay, so I never talked about any limits which are above the surface of the earth. It is not about having the search of life above the surface of the earth. It is beyond earth. We want to find life beyond earth. Okay, with respect to the surface of the earth, or with respect to the earth, we know life as it is. We are interested in finding out if there is any life or its evidence beyond earth. It could be in the solar system, it could be beyond the solar system, doesn't matter. Okay, so that is what we want to do. So now do you understand? The answer would be option C. Yes. See, earth-like planets basically means two things. One, it has the conditions of temperature and atmosphere similar to earth. Okay, now there could be difference in the composition of the atmosphere. It's not something which is wrong, but the point is it is having features like earth, that it will be rocky, it will have warm enough temperatures, and it may have an atmosphere, because without atmosphere there will be no gases which will be retained. Okay, the next thing, it will have surface water which is liquid in form. Which one? See here, the the ambiguity that you are talking about in this particular term, here you basically are arguing for habitable zone. Okay, but the point is that the same habitable zone is because we are talking about planets like earth. How do you define a habitable zone? It is only because of the life as we know it. Okay, we are someone who are able to survive at a temperature of about -40 degrees centigrade to, let us say, 50 degrees or 52 degrees centigrade. That is where we find most of the life on earth. So this is exactly the kind of situation you are looking for. So in order to characterize what life should be, you are using the entire properties of the earth. So what exactly are you searching for? Earth like planets. Okay, I told you yesterday as well that there could be a difference in how the question is asked and what exactly am I explaining. As long as you have the same concept conquering, the answer is that. Okay, I guess you are confused with this habitable zone. Hmm. No, above the surface of the earth, it does not mean that. Now that is the vague thing. Above the surface of the earth, that is basically where the vague thing is, and you assumed it to be the entire solar system. But the point is that this is something which becomes more specific in that part. Okay, that you're talking about outer space, not above the, because above the surface of the earth, even we exist. We are all living on the surface of the earth. This is not Goldilocks zone. On Earth, we know that life exists. That is why we are trying to characterize that your average distance from the central star should be about 150 million kilometers. You should have a rocky terrain. Okay, you should have some amount of atmosphere. You should have some amount of temperature so that you can sustain surface liquid water. These are the things that we are searching for in the outer space. Yeah. But this is clear to you? Yeah. Actually, when the atmosphere was studied, it was found that the atmosphere has got carbon dioxide as well as oxygen. Okay, and at the same time, it was also found by the various spacecrafts that have taken images of this that the temperatures are relatively survivable. Habitable or hospitable temperatures are possible. Not for humans, not this life, but you have something called as tardigrades. Do you know these? Search for it in Google. These are so small organisms that are found on Earth. So small, but they are one of the most resilient organisms in the entire world. They can survive extreme amount of temperature, extreme amount of you can say your atmospheric conditions. These are those organisms which are known to survive in vacuum like conditions with absolutely no air, no atmosphere, extremely frigid cold conditions. Okay, they are known to completely suspend their life, that is called as suspended animation, when they have extreme temperatures, and then subsequently when the temperatures become normal, they come back to life. One of the most resilient organisms in the world are tardigrades. So that is why they are the ones which are usually sent to many of these space experiments so that we can understand, do they live or do they die. They are found inside the volcano, around the volcano, inside the deep layers of ice, over the surface, even in the space. Even in the space in the sense International Space Station. They are living everywhere. Tardigrades. And they look very cute in the photos. Just look at that. Google it out. They look like very cute small babies, like they're always like that. Look it, no issues. You don't have a phone. Very nice. This is a very rare quality. You forgot it or you don't carry it by choice. Commendable. You live somewhere nearby. Oh. So you actively practice this or you have no interest in phones. Okay. Well, even if you don't have any interest in phone, that is also something that is saving your life and it is saving your mental space. A lot of us are very sad because of the Instagram. Not me, I don't do it, but yes, a lot of us. We have a lot of competition to take place. Okay, a lot of dissatisfaction in the world is because of social media. That is the primary reason for anxiety. Found it? So that is tardigrades for you. What was your next question? Oh, the Saturn one. So we are expecting actually the life forms like this. It may not be plants, it may not be humans, but at least them. That is what we are also finding in Mars. Okay, we have a rover there that is known as Perseverance. Perseverance is a rover from NASA. What exactly is a rover? Rover is a robot. Okay, this robot has a duty that it can negotiate over a surface. It can travel on a surface. So whatever can travel on a surface using wheels, that is known as a rover. That is why we have Range Rover. Okay, Range Rover basically means that it can go to any kind of terrain. That is its range. Okay, any kind of terrain that the car can negotiate. It could be snowy roads, it could be extremely tough hills, that could be puddles, that could be quicksand. It is able to negotiate on most of them, not all of them. So that is why it is called as Range Rover. Okay, so rover is a robot. Anyone who has participated in any of the bot wars, engineers, you should be doing that. You are a design engineer by your specialization. You should be designing one. What are you doing? So what happens is that anyone who has ever attended any robotics seminar, building your own robots. So there you might be having 4 different motors, 4 wheels, one board, right, a battery and some amount of coding, Arduino board, and you would use it like that. That is a rover. Okay, that's the thing. Understood? Okay, before we begin with this, go and take your break. It's your time for break. You get your 5 minutes. So it is, what time it is? 13:17. Okay, so come back at 13:25, 1:25. So I give you 8 minutes. Okay. We are now going to talk about meteors. So we were talking about meteor. The only difference, the astronomical object, not the bike. Yeah. So see, this is a figure for you to understand the various things: comet, meteor, meteoroid, meteoroid, and asteroid. So let us begin with first of all asteroid. Okay. Now asteroid is a broken rocky fragment that is found between Mars and Jupiter. There is a zone of this rocky objects that is known as the asteroidal belt. Okay, so there is an asteroid belt. Where do you find it? Between Mars and Jupiter. And what is exactly an asteroid? An unconsolidated rocky particle. It will not have ice, it's a rocky particle. Okay, now this rock may be having precious metals, it may be having carbon, it may be having coal, but the point is it is not going to have ice. Why no ice? Because it is found nearer to the sun, and because of this, any kind of ice that could have been found, any kind of frozen gas which could have been formed, that is something which is evaporated, vaporized. So that is why when you talk about an asteroid, that is something which orbits the sun in the similar fashion as planets. Okay, but the point is it does not have ice, these are rocky. Now they are actually maintained in that particular belt due to the balancing of gravitational force by the sun and that exerted by Jupiter and Mars. Okay, I told you gravity will act between any two objects. So force of gravitation will be there between the asteroid and a nearby planet, and between the asteroid and the sun. You will find this. Now the point being, when you talk about the asteroids, sometimes what happens is that when they are in their orbit of revolving around the sun, so what happens is that sometimes there are certain other planets which come very close to these asteroids, and then what happens is that because any other planet which is coming very close to the asteroid, they attract the asteroid towards them by gravity. Okay, and subsequently what happens is that these asteroids get knocked off from the asteroid belt. So now because you are not in the asteroid belt, so what happens? The forces which were acting on you are now unbalanced, and when the forces are unbalanced, what is going to happen? Now you are going to move in a certain direction. How exactly are you going to move? You are going to move in the direction which is pulling you. Okay, so with respect to any of the planets in the solar system, you are going to see that the effective movement will always be towards the sun, because sun is the most massive object. So when it is the most massive, it will have the strongest gravity. Once your equilibrium is disturbed, once your path is disturbed, you will go straight crashing into the sun. Okay, and when you go straight crashing into the sun at that particular moment of time, what happens? You see that you are going to cross all the planets in front of you. Some of them may just be making a crossing before you move. Some of them may be at the farther side, you do not have any issues with that. But the ones which move very close to you, while you are passing them, you will be attracted or influenced by their gravity. Okay, so whenever such objects pass across the earth, okay, they are known as meteoroid. So these are basically those fragments of asteroids, or those you can say small rocky fragments which are influenced by the gravity of the earth. Okay, so technically they are falling towards the earth, or they are going to pass very close from the earth. Okay, that is known as a meteoroid. Now what happens? Some of these fragments, they get attracted towards the surface of the earth. So when they are going to be attracted towards the surface of the earth, what happens is that they enter into the atmosphere. Okay, so when they enter into the atmosphere, so what happens is that they experience a great amount of resistance from the air, because in the atmosphere we have got air. Okay, so as these meteoroids, they start coming towards the surface of the earth, they start burning. Okay, so now they are known as a meteor. This is what you call as shooting stars in the night sky. Okay, So meteors are basically those meteoroids that are crashing towards the earth and currently burning due to the presence of air in the atmosphere. So this air in the atmosphere basically acts as a defense mechanism. Because of the enormous amount of resistance, it tries to burn off this entire object. Why? Because this object, when it is falling towards the earth, it will be again impacting the earth. It can be a significant, you can say, destruction on the surface of the earth. So that is why most of that fragment burns up here. Okay. Then subsequently what happens is that sometimes when these meteoroids pass the entire atmosphere, they stop burning. When they stop burning and they hit the surface of the earth, they are known as meteorite. So meteorite is basically the rocky fragment of a meteoroid that passes the burning phase and reaches the surface of the earth. So this is the part which is going to impact the surface of the earth. Okay. So this is going to be significantly, you can say, smaller than the meteoroid. But the point is that wherever it is going to make the impact, it is going to make a dent on the surface that will be known as a crater. Do you understand this? So this is the difference between meteoroid, meteor and meteorite. Okay. Now, wherever the meteorite is going to strike the surface, it creates a dent that is known as a crater. Okay. Now, one such crater is found in Aurangabad. Okay. In the Aurangabad district of Maharashtra, we have one such crater. Okay. And that crater right now is filled up with water. Okay. That place is known as Lonar Lake. Lonar Lake is basically a meteorite lake of India. The only meteorite lake of India is Lonar. Okay. Found in Maharashtra. Understood? During the time of COVID, this particular lake was in news because suddenly during the lockdown time, the water of this particular lake turned pink. The only instance on earth recorded where the water went pink. And it created a lot of hue and cry. Why exactly it went pink? Okay, is it something which is supernatural, or is it something which is the beginning of an alien race? Then eventually it was understood that there was some corrosion of the rocks that were exposed, and that actually imparted the pink water. Okay, so that is Lonar Lake. Now, apart from that, we have comets. Now see the difference between a meteorite and a comet. The biggest difference is that you are going to see that when a meteorite burns up, it gives you yellowish flame. When you are seeing a comet, comet will have a long flashy tail. This flashy tail is actually ice melting. Okay, so when you talk about a comet, it is an icy body. It will have rock, but it will have greater proportion of gas. It will have greater proportion of ice. So that is why when it approaches the sun, it has very long tail, white dazzling tail. Now that is basically the burning up or evaporation of the ice. Okay, the ice melts up and it gives this bright, you can say, long flash of tail. Okay, so the biggest difference between comet and asteroid is predominantly rock. Comet is predominantly gas and ice. You cannot expect the comet to have any, you can say, significant amount of material or mineral, but you can definitely expect asteroids to have minerals. Okay, there has been an asteroid which is known as Bennu. Okay, this is an asteroid which is known as Bennu. Okay, this Bennu asteroid was one of the sites of an experiment from NASA's space probe known as OSIRIS-REx. Okay, so OSIRIS-REx was a spacecraft that was commissioned by NASA. This spacecraft landed on Bennu. Okay, and this Bennu is basically an asteroid which is known to have rich carbon on the surface. So it went to this asteroid okay, got a sample and came back to the surface of the earth. Okay, similarly there has been another asteroid that goes by the name of Ryugu. Okay, now this was the site of another, you might be knowing this bike if you are all bikers. Japan actually sent a satellite with the name Hayabusa. Okay, it went to this particular asteroid and was the first one to collect a sample and come back to the surface of the earth. Okay, so it went to Ryugu and the Bennu was the one which was the site for NASA's experiment. So what are we doing right now? We are trying to analyze or evaluate the mineral composition of these two asteroids, and then subsequently we are trying to work upon those systems based upon which we can be mining minerals out of these asteroids. Okay, why exactly is this feasible? Because this is not going to create pollution on the surface of the earth for mining purposes. Yes, we will be polluting the earth with respect to development of the machines and mechanisms, but at least the mining, the environmental pollution that is related to mining will be prevented, because we are going to do it on an offsite, that is a meteor, that is an asteroid. Okay, so that is why asteroids are actually very important for us. Okay, comets are not that important with respect to mineral composition. Okay, understood? So this is basically a comparison between the two. So when you talk about a comet, the primary composition is ice, dust and some rocky material, but predominantly ice and dust. You cannot expect metallic minerals here. Okay, the next thing, the distance is far away from the earth, from the sun. It is found in the Kuiper's and Oort cloud. Then they basically are the ones who lose their mass every time they pass near the sun. Okay, a part of their ice and gas gets vaporized. So they lose their mass and ultimately they are going to completely vanish off. Okay, and their tail is because of the vaporization of the ice. But when you talk about asteroids, they are basically the ones where you are going to expect metallic minerals as well, because they are rocky. Okay, then at the same time they do not have any ice on them because they are found close to the sun. Okay, and they are basically located between Mars and Jupiter. That is the primary difference between comet and asteroid. Okay, now this was basically a question of 2018. Tell me what exactly is your answer on this. D. D. Bombay. How many? 1, 2, 3, 4. Okay. C. Anyone else with C? C. 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 Okay, head to head. Who is the one who has not answered? Or did I wrongly calculate it? What is your answer? AI? Okay. Then I wrongly calculated it. Okay. Chalo. What is the difference between asteroids and comets? Asteroids are small rocky planetoids, while comets are formed of frozen gases held together by rocky and metallic minerals. Okay. Asteroids are found mostly between the orbits of Jupiter and Mars, while comets are found mostly between Venus and Mercury. Comets show a perceptible glowing tail, while asteroids do not. Okay. Which of the statements given above is or are correct? So first of all, this was the old way of UPSC's questions which prevailed before 2023. Okay, before 2023, most of the statement based questions usually came in this format, that you were given 2 or 3 statements and you had to identify or pick and choose which of them are correct or incorrect. Since 2023, there has been a significant change, and that change is that now the questions have been changed. You will still get the statements, but instead of which of the statements given above is or are correct, it will be how many of them are correct or incorrect. Okay. So now what is going to happen, you are just going to see that in this particular question, elimination, the trick of elimination works very well. Okay. So after reading this question, you have to find out which of them are factually correct. So asteroids are found mostly between the orbits of Jupiter and Mars, while comets are found between Venus and Mercury. This is something that we know is egregiously wrong. Okay. So when this is wrong, you eliminate two options which contain this particular alternative. Now you are left with two. Okay. And this is what everyone used to bank upon. This is elimination trick, that you have eliminated two options. Now the probability of getting correct is still 50%. But yes, you have eliminated something. Now the other thing. Asteroids are small rocky planetoids, while comets are formed of frozen gases held together by rocky and metallic material. So I told you, you cannot find metallic material in comets. There may be rocks, but not metallic materials. So this is wrong. So I think the answer becomes pretty clear. Okay. Now this question, if it was asked how many of them are correct or incorrect, then it becomes a very difficult question. The same question. If I don't tell you these and I ask you only one, only two, only three, none of the above, the same question becomes tough. So that is why now the trend of UPSC is going towards knowing things completely. If you are going to read about facts, the facts should be right. If you are going to read about concepts, the concepts should be right. This is basically how UPSC dealt with the concept of elimination, which people used to flaunt about. That we have elimination and that trick could work. That works, but only till the point that you have to pick and choose the statements. Okay, even if I gave you, instead of this I gave you only one. Now consider these options. Only one, only two, only three, and none of the above. So even then you are only able to eliminate this. Now most of you are either going to take two of the statements are correct or one of the statement is correct. Even some might also feel that none of the statements are correct. The same question may change. So 2023 was not a tough paper. It was tough options. It was not a tough paper. I told you yesterday also, I showed you those questions. Pretty straightforward question, but the options have changed. Your brain was tuned with that and you were instead given this. That is what scared the students, nothing else. Okay, so understood? This is basically the difference between, for some reason it does not work with me. This is basically the question that has been asked, although old question, but these questions are the one which are, you are going to see this going repeated, just like in 2023, 2024, 2025. One question from oceanography has repeated in all the 3 years, all the 3 years. Okay, and almost the same statement, just the way that options are different. In 1 year, assertion reasoning. The other year, how many of them are correct? The third one, factually incorrect questions. That is how they are asking the questions. So questions do get repeated here. Okay. Now we move towards the next thing. Now we want to understand something known as light year. Okay. So tell me, if you have to describe the distance between two objects, what exactly are you going to use? Let us say that you want to describe the distance between you two. So how are you going to describe it? How are you going to measure the distance? Step or scale? Because your step is going to be different from my step. You may be having a distance of 1 step, my stride is half a step. Okay, so the correct way would be a scale. Okay, if you have to measure the distance between all of you, you would be using a scale or a measuring tape, something like that. Okay, but the point is that if I have to measure the distance between Bangalore and let us say Tumkur, then can I use a scale? Because I can use a scale, but the value will be very large. So what do? I change the scale. I introduce bigger units. Right now it can be said that the distance, let us say, between you two, okay, is about 80 centimeters. Eyeballing, nothing else. Okay, about 80 centimeters, or maybe between them it is about 120 centimeters. Okay, the point is that I can go on doing this till 1000 centimeters. Beyond that, can I say the distance between me and him is 3000 meters, 3000 centimeters? Will it make any sense? What happens is that when you talk about mathematics, mathematics is the subject of lazy people. Why? Because we want to save space and the energy that we are writing upon. So that is why what we do, instead of writing 3000, we'll be writing 3 kilometers, 3 meters. So that is why we have certain units, like 100 centimeters make 1 meter, 1000 meters make 1 kilometer. Okay, so what happens is that with every bigger unit, the scale changes. So now after every 1000 meter, you will be counting it as 1 kilometer. Okay, so that is how we see that the distances between two places are going to be expressed in the terms of kilometers. But if I have to tell you the distance between you two or any two of you, you would be expressing it either in centimeters or in meters. So whatever unit is comfortable for us. If I have to tell you that you have to tell me what exactly is the distance between, let us say, him and me. So will it be 0.03 kilometer? Will it make any sense to you? No. But yes, 3 meters, that does make sense, right? So that is how we see that there are various units that we use to measure distance. Okay, when you have to measure big distances, you go for bigger units. When you have to measure small distances, you go for smaller units. Do you know about nanometer? Nanometer is basically used to measure very, very small distances. And whenever we try to develop any kind of technology in that scale, that is known as nanotechnology. Okay, so nanometer is not something that we'll be able to, you can say, see with our naked eye. Just like your hair, a strand of your hair is 1 micrometer thick. Okay, 1 micrometer is 1,000th of a meter. Okay, so that is the thickness of your hair. Okay, it is known as microns or micrometer. But the point is, if I have to express it in terms of millimeters or meters, 0.00001 meter doesn't make any sense, right? You might be knowing about this thing, PM 2.5. Anyone who has heard this term? PM 2.5, PM 10. You will, but what about others? Civil engineers? Come on, dude, you guys have done this. Don't tell me you have not done this. You are the reason why we have PM 2.5 mostly, apart from mechanical engineers. PM 2.5 basically means particulate matter, okay, whose size is 2.5 micrometers. Okay, so these are so small particles that we inhale directly, and that is unable to be filtered by the nasal hair. So when these particles get inside our respiratory system, they cause distress because these are foreign objects. So our body has a mechanism that whenever anything foreign object or foreign body comes into our system, our body triggers an immune response. So because of that immune response, we start feeling cough. We will cough, we will sneeze, we'll have mucus that will start clogging this so that it does not damage our body. That is the whole reason you have cold. Okay, cold basically happens because your nasal cavity and your throat cavity, these two are the inlets for air to get inside you. Okay, so if there is any kind of foreign object that has reached your lungs, okay, so now the body thinks that this foreign object is something that will damage your lungs. So it is always in that particular mode that I have to defend my body. Even if you don't want to, it wants to defend the body. Okay, so what happens? It attacks that thing. So in order to attack that thing, what it happens is that it creates a thick sticky layer of liquid like substance known as mucus, that is known as cuff when you expel it out. Okay, so there is a thick lining of mucus that comes up here. There is a thick lining of mucus that comes up here, which makes you feel clogged. You are not able to breathe. You may not be able to speak properly, but that is made by the body in order to be very, very sticky. That is why it remains with you for the next 3, 4, 5 days. Okay, and that is made sticky because anything that is coming in, when you are breathing in, so whatever particles are coming in, whatever dust is coming in, it will get stuck there. Okay, so that is why in the morning, after you have slept, in the morning when you wake up and when you expel out that cuff, you will find that it is not usually yellowish in color, it will be a little blackish in color depending upon where you are. That is basically where it has clogged the dust particles which were there in the air and that were actually getting in. Okay, so that is how the immune response works. Okay, so PM 2.5 basically tells you the size of the particle is 2.5 micrometers. So small that you are not able to see it by naked eye. Okay, if your strand of hair falls on you can say any of the table, you will not be able to notice it. Okay, a single strand of hair you will not be able to notice, but this single strand of hair, if it actually falls into a cup of white milk, you will count it. Okay, so that is the perspective of distance or length. Now when we talk about length or distance, we talk about in terms of places on the earth, we say thousands of kilometers, still something which is manageable. But what about moon? So moon is basically 3,84,000 kilometers away from earth. Okay, so 3,84,000 is still something that we can deal with. How about sun? So sun, we said 150 million kilometers away from earth. Okay, how about Andromeda? Now no million of kilometers are going to work. So there what we have, the scale changes. There we use something known as light year. Okay, so light year, it may sound as it is a unit of time, because years you usually say what is your age, so you tell this many years. But when you talk about a light year is a measure of distance. Okay, remember this. This is one of the first you can say steps where we get confused, that light year is a measure of distance. Now if it is the measure of distance, whose distance? The distance that will be traveled by light in 1 year, that is basically known as light year. So yesterday I told you a formula of speed, that speed is equals to distance upon time, right? So with respect to light year, we know that speed of light is 3 into 10 to the power 8 meter per second. This is something which is experimentally determined by us, that the speed of light in vacuum is 3 into 10 to the power 8 meter per second. Okay, now tell me that in 1 year how many days are there? Let us do it here. Okay, so we have the formula, speed is equals to distance upon time. Okay, so we have seen that speed of light in vacuum three into 10 to the power 8 meter per second. Okay, so time in 1 year. So 1 year is basically 365 days. Agreed? We are not considering leap year. So 365 days. Every day has 24 hours. So 365 into 24 hours, right? Every hour has 60 minutes. And every minute has 60 seconds. So this is basically the time in seconds in 1 year. Okay. So in 1 year, these are the number of seconds which will be present, and in 1 year, the speed of light is going to be this all the time. So if I now multiply speed into time, will I get distance traveled by light? If I multiply this with this, will I get the distance traveled by light? Why am I multiplying this with this? Because here the unit is in seconds and here the unit is in seconds. So I can multiply this with this, not with others. Okay. So meter per second. So when I multiply these two, will I get the distance that is traveled by light in 1 year? That is what is known as a light year. Okay. So what is the distance that is traveled by light in 1 year? This is the distance in kilometers that is traveled. 9.46 into 10 to the power 12 kilometers. So after 1, there are 12 zeros. Those many kilometers are there in 1 light year. Okay. So that is how we are able to characterize the distance between far objects. Okay, very, very far objects. And the only reason we are able to do this is because light always travels at a constant speed in vacuum. Okay, that is the only reason we are able to do this. Do you understand this? So when you talk about the you can say the light, the time the light takes from the sun to reach towards the earth during the daytime, so it's about 8.3 minutes. Okay, so we have the time of light that is taken, we have the speed of light. When we multiply these two, we get the distance between the sun and the earth. So that comes out to be 150 million kilometers. That is the average distance of the earth from the sun. Okay. Subsequently, if we basically have to say the nearest star after sun. Okay. So the nearest star after sun, I told you, is Proxima Centauri. That is 4.3 light years away. So this multiplied by 4.3 kilometers. Very, very far away. Okay. Then at the same time, we also try to imagine the size of solar system, or for that matter, imagine the size of Milky Way galaxy. That is also something which is done with respect to light years. Now when you talk about Polaris, yesterday we talked about Polaris, North Star. Okay, it is 320 light years away from Earth. But because it is aligned very, very closely to the axis of rotation, it always points towards the moon. So see what is the distance, great distance. Okay. Now subsequently what happens, if we basically have to characterize the size of Milky Way galaxy, that is also something done with the you can say light year. So there what we try to find out, what is the time taken by light to reach from one end of the Milky Way galaxy to the other end. Okay, we characterize that time, we know the speed of light, we get the diameter of Milky Way galaxy. That is how light years is used, okay, to characterize the size of various astronomical objects which are far away beyond solar system. Okay, understood? So this is light year. Now the next thing, okay, this is the final slide of this presentation, and then subsequently tomorrow we'll be starting with the theory. What we also do is that we say that the distance between the sun and the earth, which is 150 million kilometers, we also call the same thing as astronomical unit. Okay, so one astronomical unit, it is abbreviated as AU. So one astronomical unit is equal to distance between the sun and earth, and this is 150 into 10 to the power 6 kilometers, which is 150 million kilometers. So one astronomical unit is this. Now this becomes a little important as well. Okay, we have two very, very important you can say space probes right now. One of them is called James Webb Space Telescope, and the other one is called as Aditya L1. Okay, so these are two space probes. When you talk about Aditya L1, this is ISRO. When you talk about James Webb Space Telescope, it is NASA. Okay, when you talk about Aditya L1, it is positioned between Sun and Earth. It is positioned between Sun and Earth. So Aditya L1 is facing the Sun. It is basically a way in which we are trying to study the atmosphere and the layers of Sun. Okay, when you talk about James Webb Space Telescope, it is located away on the other side of the Earth and Sun system. Okay, both of them are present at a distance of 1.5 million kilometers from the Earth. Okay, both of them are present at 1.5 million kilometers from Earth. The only difference, this is present at a point called L1. Okay, this is something which is present at a point called L2. So L1 is here, L2 is somewhere here. What are these? We'll discuss tomorrow. Lagrange points. Okay, we'll do that tomorrow. But the point is, both of them are at exact same distance, only on the opposite side. Now, UPSC may confuse you. How? Because both of them have very similar figures as 150 million kilometers. So can you tell me, if they are away by at 1.5 million kilometers, okay, so how many astronomical units are they away? Okay, so one astronomical unit is 150 million kilometers. They are present at a distance of 1.5 million kilometers. So how many astronomical units? 100 or 0.01? It will not be 100. It will be 0.01. So either the UPSC can ask you that these are located at a distance of 1.5 million kilometers from the Earth, or they are located at a distance of 0.01 astronomical unit from the surface of the Earth. Both of them will be factually correct. Or UPSC may ask you that they are located at a distance of 1 astronomical unit from the surface of the Earth. So that will be wrong, because 1 astronomical unit is 150 million kilometers, and 1 astronomical unit is the distance between Sun and Earth. So if they are placed that far away, there is no L1, that is Sun. So this is how you identify the factually incorrect statement. Are you getting this or not? Is there any confusion with respect to this? Understood? Everyone is clear with this? Now, is light year the largest unit of distance with respect to astronomy? No. There are bigger units as well. Okay. There is another unit which is known as parsec. And 1 parsec is equal to 3.26 light years. So when the objects are even farther away, we can use this particular unit of distance as well, parsec. Okay, so light year is not the biggest unit to measure distance. Understood? Everyone? I'm changing the slide. There you go. UPSC 2021. 2020 or 2021? How many with D? Wow. This is absolute majority. So see how a small concept also gets asked in UPSC. And most of the students got this question wrong during UPSC in 2021. Most of the people did not know the reason. Okay, so that is how it is. So that's the answer to this question. So we are done for the day. Okay, you're done with the first part. So right now, technically, what is the progress that you have made? You have understood the terms of universe, you have understood the fundamental terminology, you have understood the solar system. Now I would want you to go back to your places and read first chapter of class 6th. Okay, read class 6th geography. Okay, the first chapter is Earth and solar system. Read that chapter, and apart from that, after you're done reading it, read the first chapter of class 11th NCERT physical geography. That is again going with the same name, origin and evolution of the Earth. So in the beginning, first 3 pages, you are going to find the theories of the evolution of Earth. Okay, Earth and universe. Just read that part. Tomorrow we begin with that. Tomorrow is a Sunday or what? Okay, so I guess unfortunately you guys have a class. Okay, so you are going to have that particular session tomorrow. We'll be discussing it in detail. Even if you do not understand what is written in NCERT class 11, no issue. Tomorrow I will be giving you an exploded view of everything there. Why is anything happening? What are the physical principles involved? What are the forces involved? And you will then be able to figure it out. Even if you are not able to understand it right now, no issue. Just read it. But read your class 6 NCERT now. You are done with it. Okay, class 6 first chapter, you are done. Okay? Okay, then see you tomorrow. Bye-bye. Any doubts?